Hello and welcome. In this video, we're going to learn on how to write lines of codes for K-means clustering algorithm. As we all know that K-means clustering algorithm is a non-supervised machine learning algorithm. So we will learn how to write the lines of codes for that. Before we start, if you have any confusion or questions regarding how distances are calculated in machine learning algorithms, I would recommend you to watch one of my previous videos in which I am talking about various distances, including Euclidean distances, Manhattan distances, and Minkowski distances, and how these distances are calculated and used in various algorithms. I recommend you to watch that video. I will provide the link to that video in the description box. Please click on that and watch that as well. So first things first, let's get all the required or necessary libraries to this particular algorithm. So first thing is I need a pandas. So I'm going to import pandas as PD. And then I will import numpy as NP. And then I will need for visualization import matplotlib dot pyplot as PLT. And I'll need few libraries from sklearn to run KMeans. So first is from sklearn.metrics. I need something called as silhouette score. So I will silhouette underscore score. And then from again, so I'll need to import this. So import, I'll write it here. And again from sklearn dot cluster, I need something to be imported, which is called as K-means. Okay. So these are the things which I will need. Shift and enter. Kernel is busy. I see that it's getting imported. Okay. So it will be done. Okay. Now it is imported. Now we will come to selecting the data for this algorithm. So I've already stored that data in my laptop. The file's name is malls customer. So I will use this as the data variable name data itself, and then I've used pandas, and I'll ask it to read CSV file pd.read CSV file, and I'll provide the name as what I've provided in my storage. So I've provided as mall underscore customers, and it is a CSV file. Okay, shift and enter. So the data is also accessed now. So if I have to look at the data, I'll put data.head. So first 5 records will pop up, and this is the data. Okay, so let me speak a few words about the data. The analysis we are planning to do is on the recordings of certain customers who visited a mall, and we gathered information regarding their gender, their age, how much do they earn, which is the annual income, and what correspondingly a spending score has been devised. So we have around 200 records in this, and we want to only focus on these two areas, annual income and spending score, and create a cluster algorithm for that so that we can cluster various customers into different groups, and we can start on our marketing initiatives. So obviously, your marketing strategy will be different for a high income, high spending person compared to a low income, low spending person. So these are the clusters you want to find out, okay, and have your marketing strategies there. So initially, I will not need these three columns. All I'll be focusing is annual income and spending score. So maybe I will create a variable called as x, and I will say that data.ilog. Okay, and select all the rows, but I need just column 3 and 4. Column 3 and 4 means index 3 and 4, 0, 1, 2, 3, and 4. So I'll call 3 and 4 and store that as NP array. So values, dot values. So X will be NP array. Shift and enter. So this is stored as an array. The now next question is, okay, we are doing k-means clustering. So K stands for, in k-means clustering, K stands for number of clusters required, okay, or number of clusters. So how do you find out how many clusters will you need? For that, there is a method available to you. You just need to run that So that method is going to tell you what will be the right number of clusters you should be using. And that method is called as an elbow method or a scree plot, we call it. Okay. And in the elbow method, what we are going to use is a term called as within cluster sum of square numbers. Sum of square numbers you will be knowing. Basically, it is the square of the distances from a particular centroid or the mid value to the remaining data points. So obviously, our intention is to reduce the sum of squares. When sum of squares are reduced, you will see that within a cluster, the data points will be as close as possible to the centroid. So that means what it shows is that it is a homogeneous cluster. So your objective is to reduce sum of squares, but it is not to completely minimize it. It is to find balance between how many clusters do you need, and for that given number of clusters, what will be the most desirable sum of square values. And that is what elbow plot is going to give you. Okay, now let's quickly look at how do we construct an elbow plot. So first, as I told you, we will create a variable within cluster sum of squares. We call it as WCSS, and I will create an empty list for that. Then I'm going to write a loop for I in range of 1 to 20. So why 1 to 20? I is going to represent the number of clusters. So I'm going to do a trial and error and see that, okay, I will substitute this first cluster and I will go till 20th cluster, compute the WCSS value and find out which is the optimal value. Okay, so first I will do that. And then what I need is I'm going to define k-means. Okay, k-means we have already downloaded here and kept. Okay, so k-means and to parenthesis and shift. Whenever you do not want to make a mistake, if you want to be very sure, just write the imported library's name and then click on the middle of the parenthesis and shift particular window will come. So these are the arguments you will be providing within that. Okay, so I want to give, obviously, I want to change the value of the number of clusters. I want to give it as I because I want to substitute this I from 1 to 20 in here. And then how do I decide on the initial clusters? I want that initiation to happen with this particular method, which is called as k-means plus plus, which is a probability distribution. Are asking many Jupyter nodes or Python to basically select it randomly, and the algorithm used for that or the selection method is k-means plus plus. And then I want to randomize my data, random state I will put and start the selection from any of the row. I'll give it as 42. You can give any number, it doesn't matter, but it's basically need to be randomized. This is your requirement. So k-means is done. And now I'm going to fit the values k-means dot fit and fit it with X. Okay. Now the next question is how do I calculate weighted cluster sum of squares? So within cluster sum of squares, I can calculate and then I want that value to be appended into this empty list. So what I will do is WCSS dot, I'll say that appended with what? Appended with k-means dot inertia. K-means dot inertia means this particular inertia will give this particular value, and this empty list will get appended with different WCCS values for different clusters. So it starts from 1 to 20. So you'll get 10 different. So shift and enter, you see that this WCS value is generated and kept. Now for all practical reasons, you want to visualize this, right? You want to create the elbow plot. So what I will do is I will use matplot plt dot plot. What do I want to plot? I want to plot x and y. What is the x here, guys? X is the range of 1 to 20, isn't it? I want this as my x variable, and my y variable will be w CSS. Okay. And if I click shift and enter, it's going to create a graph for me, a beautiful graph. Okay. Now what I want, I'll before I look at the graph, I will give the x values and x label. Okay. So plt dot x label label is equal to what is the x label you want to give? You will say number of clusters. And for y label, you will say plt dot y label, and that is equal to, you will, not equal to, you don't really need equal to here, as what do you want, w SSS. Okay. And then what you will do is you want to give a title to this. So PLT dot title, and that title you're planning to give it is maybe elbow plot, whatever. And finally you'll say PLT dot show to show the graph for you. Let's see. Yeah. So I'll close this. We don't need this anymore. So elbow plot, and this is the weight within cluster sum of square value, and these are the number of clusters. So it starts from 1 and it goes up to 20. Okay. So here it looks like an elbow, isn't it? If you really extend your hand and flex your arms, you'll see that it is like an elbow. What you should do here is whenever this elbow is getting straightened up, that means you had a higher WCS or sum of squared values here when you had lower clusters. Obviously, if you have only one cluster and you are trying to fit all the data points into that particular cluster, obviously your sum of squares will be higher. But as and when you increase the number of clusters, you see particular point where your elbow is actually bent. And afterwards, you see that sum of squares is reducing gradually. So obviously, when I have 200 observations, if you have got 200 clusters, this SSC is the sum of square is going to be the minimum there. But what's the point? I want a sensible number of clusters. So here I will always look at my elbow plot and see where is my elbow coming. That means significant reduction happened, and there is a point at which the reduction is going to be very minimal, and it is not adding any value to me because unnecessarily increasing clusters does not help me. So I will pick up this, and the number of initial clusters required is 5. So I get this value of 5 from my elbow plot. Now I want to create the clustering algorithm. So here it is very simple. So I will again call it as KMeans itself. So K means, and I'll shift and tab. I'm going to get these values. So here instead of 8, now that you have done your elbow plot, you know how many clusters do you need. It's equal to 5, isn't it? So 5. And then the method is again the same. I want to use the init method as KMeans plus plus itself. The reason why I'm copy pasting this, I'm trying to give you this habit so that you will also not make a mistake and you don't need to spend time in basically troubleshooting. And random state, if you want to copy that also, you can copy or you can type whatever random state. You can give any value. I'll give the value as 42. Okay. So that's perfectly all right here. And the k-means algorithm is set. I will create the y values. Okay. So, or y k-means. These k-means are nothing but the predicted value. So I'll say that k-means dot fit underscore predict. And what am I using to predict? My x values. Okay. So this is basically y k-means for me. And I'm going to fit and predict this particular x value. So that becomes my y predicted value. Okay, shift and enter. So if you want to look at what does y means, you see that print y k means, right? You see that these are the clusters. So 0, 1, 2, 3, and 4, 5 clusters you have. These are the predicted values. Now I'll need to create the clustering plot for me. Okay, so that is for representation. I need to look at all these clusters and I want to see how these clustering plots will be created. So for that, I will say plot. Okay, plot the clustering scatter for me, scatter, and the x value should be obviously my x values are these and the y values are wanted, right? So I will use x and I will use the value of all the rows and I just need the third value and then x again. This is my y value, okay, and all the rows and then I need 4. Okay, so this will create a scatter plot for me. Shift and enter. You see that a scatter. Okay, sorry. See, guys, this is a mistake what I've created. I used 3 and 4, but this is data. I have reduced this to X. So X will have only two columns in it, annual income and spending score. So it won't be 3 and 4 anymore. It will be 0 and 1. Okay. So instead of 3 here, I'll have to give 0. This is the mistake what I made. So guys, please be careful. And 0 and 1. So you see, this is your annual income, and this is your spending score. X and Y is done. So if you want to create clusters, so Y means you have already created the classification, isn't it? So if I want to give that classification already, what I will do is I will say use color. Okay, using this Y means categories, please. Okay, if you use, you do color coding according to this and classify this and give it to me. So what I will do, shift and enter, I'll show you. See, most beautiful 5 different clusters have been. So for color coding, it is using cluster number 5, cluster number 4, 3, 2, and 1. 5 clusters, right? This is one cluster. One, two, three, four, and 5 clusters. Now, if you want to reduce or increase the size of these dots, you can use, you can call it as, say, S is the variable for that, and you say that, okay, 60 or 100 you can give. And then CMAP, your color code, this is a by default RGB thing. You have different settings. Say if you want to have a color map, you can give color map here, and you can say that CMAP, you can give maybe plasma. This is one of the options available. Plasma will give you different types of colors, so very attractive. So I've made it, the colors are different here. Plasma colors have been chosen, and the S is not nothing but the size of these dots. So if you want to reduce it, you just need to reduce S and give it a 70. Okay, so shift 70. So the dots have been reduced here for like clusters. Now what I want is those values or the cluster heads, right? So what I will do is I will have to go back to this drawing board and save the labels and center cluster centroids for me. So I'll say that centroid, I'll give centroid as the value. Centroid, how will I get it? So I'll say K means dot cluster underscore center. Okay. K means dot cluster center. Okay. And then if I want to have labels, if I want to know what are the labels available, so labels, I'll say K means dot labels. Okay. Yeah. Cluster center. Shift and enter. Cluster center centers. I've got multiple centers, right? So cluster centers and labels, no attributes, labels. K means labels. See, spelling mistake. Labels, labels. So that has been covered now. So centroid is stored here and labels have been stored here. So now I will also ask, create another scatter plot for me, say plt.scatter. And in here, what I want is the centroid values. You have two coordinates for centroids, right? You will have an x coordinate and the right y coordinate. So what I want to use centroid, the first x coordinate should be centroid. Okay, centroid is this, and then I will ask entire row and then give me 0, right? 0 value. And for as y value, I need centroid C, and I'll go centroid 1. So what are these centroid, guys? So if you want to really see, I will block it. I'll call centroids and give it, show you what is centroids. First, print says centroids. So print centroids. See centroids. I have not given S here. Centroid. Copy this and paste it here if you are doubtful of making mistakes. Say centroid. See, you see print centroid. These are the centroid points. So 55 on the x-axis and 49 on the y-axis. So somewhere 55 on the x-axis and 49. So this will become first centroid. And 82 on the y x-axis, 82 here, and then 17 here. So 17 this. So these are the points where I want the centroid, the point centroids to be available. So I do not want this anymore. I will just say, please plot a scatter using the centroid values. Okay. So centroid value 0 will be these values, centroid value 1 will be these value. Okay. And shift and enter. I'll show you how it works. See, you see all these beautiful dots. You can change the color of these dots and the size of these dots. How? I'll say that, okay, use the color. Say color is equal to, I want red color. So I will put red. C is red. And then S value, say maybe slightly higher than the S value you've given here. These values are 70. So you can even give a 200 there. Okay. And shift and enter. You see? Okay. So this are the 5 different clusters available to you. Okay. This is cluster 1, 2, 3, 4, and 5. So you see that this is a beautiful analysis where it shows that uh, and now before that, I want to give some more variables. Say plt dot x labels, x l a b e l, okay, is equal to what is x label? X label is your annual annual income, and what is your y label? And y label plt dot y label is nothing but your spending score. Do this, guys, because it will make your graph clearer. And then the plot plt dot title, I'm going to give that title. It's not equal to, guys. It is not required. It's not required. Equal to is not required. And title, I want to give this as cluster plot. And here, clustering algorithm, cluster plot. We are creating a cluster plot now. Okay. Cluster plot. Shift and enter. So cluster plot, this is the spending score. So you see that Anil's income is low in this area and the spending score is low. So this particular group of customers are people who are earning less than 40K and spending score is also 40. So the marketing strategy used for this people will be totally different to this group where I have an income of more than 70K, my spending habits are also more. So if I create a lot of commercial advertisements in this focusing this group, obviously my spending possibility will be really high. And this particular group, again, I have high earning capacity, but I am kind of a miser. So your return on investment on your marketing initiatives for this particular group will be very, very less. So it is basically to create that strategy, okay, and how to basically channelize your efforts in marketing. This is one of the examples. Now I have another score, silhouette score we were talking about, isn't it? This score will also help you in multiple ways to see whether the number of sectors whether you have selected is correct or not. It's another way of validating other than the elbow plot. So now let's see how we can do that. So I will again create a silhouette score, SHC I'll call, and I will create an empty list. And here what I will do is I will again now I'll create a for loop for I in range of 2 to 20. See, guys, I've used 2 to 20 years. That silhouette score will not work when you have only one cluster. You need to have minimum 2 clusters, otherwise, it'll throw an error. So, that is the reason why I just put 2 clusters here. And then what I'm going to do is K means again, K means is equal to, I'm going to use K means and shift tab. So, number of clusters here again it is going to go back and now what is the number of clusters you want to give, so I, okay, so it is going to create that algorithm again for you. And then initiation, again same thing, initiation, I'm going to use this particular initiation technique and randomize it. Okay, and I will randomize it. Random state, I will give state is equal to say 42. So now what you are preparing is a k-means to basically use these algorithms. And then from here, okay, I want to calculate what is my silhouette score. So how do I calculate my silhouette score? So I have a technique here. So now I will create the fit for it. So I'll say KMeans dot fit, and then is with your X values. And now I want to create the labels. Okay, so I'll say probably Y labels is equal to KMeans dot labels. Okay, so these are nothing but the labels of clustering, cluster 1, 0, 2, 3, and 4. Okay, so that is done. So how many ever clusters you are asking in here, that will be created. And then finally, I'll ask shc dot append with what? I want to append that with silhouette score, this particular thing, silhouette score. Okay, and then I'm going to silhouette score, append silhouette score, and silhouette score shift and tab. If you ask, will give you what are the arguments you need to give. So silhouette score first argument is what you need to give is the x. So in this case, I know what is my x, and my y argument is nothing but my labels. Okay, so y labels are my second argument. So I'll keep this as second argument. Okay, so now I have got my silhouette scores appended into this particular thing. And now I need to create a plot. Okay, so I'll do plt.plot and plot what? I want to plot the number of clusters. That means range 2 to 20. And then what is my y value? It's my silhouette score. So silhouette SHC. Okay, so this is what I want to plot. So I will see what is my silhouette scores for different range from 2 to 20. Okay, and I can run this first, and I'll show you how we take some decisions out of it. Okay, so let me close this. You see that it's a beautiful silhouette score. So here the x-axis is nothing but the number of clusters, and y-axis is the silhouette scores. So let me name it also for your benefit. So plt dot x label, okay, and that x label is nothing but number of clusters, and my y label plt dot y label is nothing but the silhouette score, right? Silhouette score, or I can silhouette score this. I can copy and paste here so that I don't need to type it again. And then I will plt dot title. I will say that a silhouette score plot. Okay, and finally plt dot show. So what is this graph all about now? Module map has no YLABL. You see LABEL. See, the spellings are important. I made a mistake here, and that is the reason it basically threw an error. So number of clusters, number of silhouette score. So silhouette score, guys, is a variable which ranges from -1 to +1. -1 shows that the clustering does not make any sense because clusters what you have made is not close enough. 0 shows that there are overlapping situations. And when it is more than 0 towards 1, it shows that you have a perfect segregation. That means within a cluster, say cluster 1, you have the sum of square values really less, and other clusters are really far also. So obviously you are able to create a cluster which is really closer within the centroid, and this particular values are really far. So these values are far, these values are far. So looking at the silhouette score, you see that silhouette score is maximum when I have got 5 clusters, and that is 55. Positive 5. But if I have got more than 5 clusters, the silhouette scores are less. That means you will not have a homogeneous mixture better than 5 clusters, even if you take 4 or more than 5. So this is another way of validating silhouette scores. So using this silhouette scores, you can also double check whether the number five, what you have taken with the elbow plot, is making sense or not. I think that you understood the concept of K-means clustering, and these are the codes. Please practice these codes. Okay. Bye for now and have fun.